Hi everyone, this is Rahul Chaturvedi and you are watching Telecom Notes. And if you have not subscribed yet, please subscribe this channel and stay connected and press the bell icon too so that you will get the notifications for the upcoming videos. So today we are discussing about SIBs, System Information Blocks. So let's start with this. First, coming to the slide of basics of SIB, the question arises, there are multiple questions that arises. The first one is why SIBs are needed. SIBs carry relevant information for the UE, which helps the UE to access a cell, perform cell reselection, information related to intra-frequency, interfrequency, and IRAT cell selections. On which channels SIBs are transmitted? It's BCCH, that is broadcast control channel, and after that it has been just mapped over DLSCH, downlink shared channel, and after that it has been just mapped over PDSCH, physical downlink shared channel. The BCCH is your logical channel, DLSCH is your transport channel, and PDSCH is your physical channel. So that question arises is minimum of how many SIBs are required for the UE to initiate attach procedure. Basically there are two SIBs, SIB 1 and SIB 2, that are minimum there are the minimum SIBs that are required to just go for the initiation of the attach procedure. So in LTE, for a UE to access the eNode B, at the most minimum two SIBs are required, SIB 1 and SIB 2. Now coming to the next slide, scheduling of SIBs. SIBs use a fixed schedule with a periodicity of 80 ms and repetition made within 80 ms. The first transmission of SIB 1 is scheduled in subframe 5 for radio frames for which the SFN subframe number mode 8 should be 0, and the repetition are scheduled in subframe 5 of all other radio frames for which subframe number mode 2 should be 0. Scheduling of other SIBs, that is SIB to SIB 9, is defined by SI periodicity and SI window length, that is there are the parameters that comes under the SIB. Both these IEs are explained below. For the rest of the SIBs, paging is received by UE in RRC idle and RRC connected mode for notification of an incoming SI message. So how is SIB transmitted? SIB is transmitted by the eNode B using the PDCCH or PDSCH. The PDCCH will carry DCI, that is having multiple formats. So there is a particular format used for the SIBs, that format 1A, that is scrambled with the SIRNTI. In the same subframe, SIB is encoded by the MAC layer 2 as the physical layer transport block, which will be taken by the PDSCH encoder on the layer 1, and the layer 1 will add 24-bit TB CRC and CB CRC, cyclic redundancy checks. The SIB TB will undergo the same process as other TBs would go, but the SIB is always transmitted using the single antenna or transmit diversity. It never go for the MIMO mode. How will UE know when to decode SIB? There are several SIB messages, SIB 1, 2, 3 and so on. The SIB 1 is a fixed periodicity that is having the periodicity of 20 ms and it's on subframe 5 always. This is known to the UE and it will look for PDCCH with SIRNTI on the particular radio frame subframe combination. Once it decodes SIB 1, it will be able to know periodicities of other SIB messages. Now starting from the SIB 1, so SIB 1 contains the information regarding whether or not UE is allowed to access the LTE cell. It also defines the scheduling of other SIBs. It carries cell ID, MCC, mobile country code, MNC, mobile network code, TAC, tracking area code, SIB, system information block mapping. Coming to the signaling radio bearer, it's NA, that means none. RLC mode, uh, radio RLC mode is TM, that is the transparent mode. Logical channel is BCCH, broadcast control channel. Direction is from E node B to UE. SIB1 is broadcasted at every 80 ms and is repeated or made within 80 ms. The first transmission is made at the subframe 5, which is having the SFN mode 8 should be 0. Repetitions are scheduled in subframe 5, for which SFN mode 2 should be 0. Now you can have a look at the left hand side of the slide. There are the multiple messages of layer 3 that comes under the SIB1. One by one we'll just have a look over each and every message that is coming to the PLMN identity. As you can see, it's having MCC 0, MCC 1, MCC 2 and two MNCs, MNC 0 and MNC 1. So it consists of MCC and MNC. The first listed one is the primary PLMN. Coming to tracking area code, tag, which is the common for the PLMN identities. Cell identity identifies a cell within the PLMN. Cell barred, if barred then the U is allowed to camp on the cell. Intra-frequency reselection, if enabled, U is able to perform cell reselection to intra-frequency cells. QRX level minimum required RX level in the cell. QRX minimum offset, that will be afterwards I'll tell you. Pmax, value applicable for the cell if absent. The UE applies the maximum power according to the UE capability. If E node B configures the value more than the value supported by the UE, then UE will set the maximum value supported by the UE capability. Example, UE category 3 supports maximum 23 dB. Okay, coming to the next messages, that is RX level minimum offset, only applied when the cell is evaluated for cell selection as a result of a periodic search for the higher priority PLMN while camped normally on a VPLMN. Frequency band indicator indicates the EUTRA operating band. Scheduling information list, information regarding the presence of SIB type other than SIB1. SI periodicity is the periodicity of the SI message in the radio frames. Then the mapping info carries the list of the SIBs mapped. SIB2 is always present in the first element of the SIB scheduling info list. Then the window length, specify that the SIB should be transmitted somewhere within the specified window length. Value is in ms. This window starts at the starting subframe of the mentioned SI periodicity. SIBs can be received in any of the subframe as the mentioned in the window length. System info value tag indicates if a change has occurred in the SI message. Coming to SIB2, it carries the common channel as well as shared information. It also carries RRC, uplink, power control, preamble power ramping, uplink cyclic prefix length, subframe hopping, uplink ERFCN. Coming to the signaling radio bearer, again none. RLC mode, transparent mode, logical channel BCCH, that is being just mapped over DLSCH in the transport layer. And after that, when the terms comes for the physical channels, it has been just mapped on PDSCH, physical downlink shared channel. The direction for EUTRAN to UE. And at the right hand side you can have a look over the messages, that what are the messages that we are just going through one by one in our next slides. So start reading one by one about each and every message. It's RRC configuration used to specify common radio resource configuration in the system information and in the mobility control information. Preambles group A config exist provides the configuration for preamble grouping. If the field is not signaled, the size of the random access preamble group A is equal to number of RA preambles. Number of RA preambles, number of non-dedicated random access preambles that are just sent by the UE to the network at the starting of the one. Power ramping step, it's the power ramping factor. Preamble initiation, initial receive target power, initial preamble power. I'm highlighting that particular channels configuration. Okay, now coming to the preamble transmax. This is maximum number of preamble transmission. RA response window size, duration of RA response window size, values in subframes, values SF2 corresponds to 2 subframes. MAC contention resolution timer, timer for contention resolution. For the contention resolution, it will be just covered in the random access procedure. In that particular video, I'll just cover this particular portion, contention resolution, in detail. So continuing this one, value in subframes, value SF8 corresponds to 8 subframes. Maximum HARC message 3, transmission 4. Maximum number of messages 3, HARC transmissions used for contention based random access. These are the channel configurations that will be just covered in the detail when we are just studying about the overheads as well as for each and every channel in detail. Uplink power control common, used to specify parameters for uplink power control in the system information and in the dedicated signaling. Frequency info is the same one. Time alignment timer common, used to control how long the UE is considered uplink time, aligned value in subframes. Coming to the SIB3, it carries cell reselection information as well as intra-frequency cell reselection information. Coming to the specifications, signaling radio bearer is NA, RLC mode, transparent mode, logical channel again BCCH, direction from network to UE, that means E-node B to UE. In SIB3 you will find these messages. One by one we will studying about the details of this one. Cell reselection information common. Cell it's for cell. Hysteresis. They specify the hysteresis value for cell deselection ranking criteria. The specified value is added to the serving cell RSRP measurement. Speed state reselection parse exist. Speed depends reselection parameters. If this field is absent, then the mobility state parameters is not present. The hysteresis subframe is present, then it is added to Q hysteresis carrier minus values so as to reduce the ranking of the serving cell and allows the cell reselection occur easily. Cell reselection serving frequency info, information of cell reselection in interfrequency and IRET cells. Non-interest search used to trigger interfrequency and IRET frequency measurements for cell reselection when target interfrequency has lower or equal priority. The second, IRET frequency has a lower priority. In IRET, there are multiple points. Specify the SRX level threshold, that is in dB, for EU trend interfrequency and IRET measurements. The second point, uh, if the fields S non-intra-search P is present, the UE applies the value S non-intra-search P. Otherwise, if neither S non-intra-search nor S non-intra-search P is present, the UE applies the default value for infinite. And threshold serving low, they specify the SRX threshold, that is in dB, below which the serving cell must fall before reselection towards a lower priority rate of frequency. Values are in between 0 to 31 dB. Cell reselection priority explains the absolute priority of the concerned serving cell frequency set of frequencies for the GRAN. Band classes for the CDMA 2000 as used by the cell reselection procedure corresponds with the parameter priority values in between 0 to 7, which means 0 means the lowest priority. Intra-frequency cell reselection information. Cell reselection information common for intra-frequency cells. It's having again the RX level minimum and intra-search. So RX level minimum required RSRP for cell reselection having the value -70 to -22 dBm. Coming to the intra-search, used to trigger intra-frequency measurements. Second, specify the SRX threshold, that is in dB, for intra-frequency measurements. The third point, if the fields S intra-search P is present, the UE applies the value of S intra-search P instead. Otherwise, if neither intra-search nor S intra-search P is present, the UE applies the default value of infinite for S intra-search P. Okay, coming to the presence. Antenna port 1 is used to indicate whether all the neighboring cells use antenna port 1. When set to true, the UE may assume that at least 2 cell specific antenna ports are used in the neighboring cells. Neighbor cell configuration used to provide the information related to MBSFN and TDD ULDL configuration for the neighbor cells. Pmax is the maximum allowed uplink transmitted power for intra-frequency neighboring EU cells. If absent, the UE applies the maximum power according to the UE capability. Coming to SIB4, carries the intra-frequency neighbors on same frequency, carries same cell and neighbor cell frequencies required for cell reselection, as well as handover between the same rate base stations and different rate base stations, that is maybe from GSM to WCDMA, GSM to LTE, or between WCDMA to LTE, and much more. Okay, so the bearer is NA in this, the same also. RLC mode, the transparent mode. Logical channels, again BCCH. It's been just mapped to BCCH, DLSCH, and PDSCH. The direction from EU trend to UE. And at the right hand side, you can have a look what are the messages that comes under the SIB4. Okay, start reading that particular messages one by one. Intra-frequency neighbor cell list. It's having the physical cell ID, offset cell. So in the cell list, it's list of intra-frequency neighbor cells with specific cell reselection parameters. Physical cell ID, it's PCI of the neighbor cell. Offset cell, specify the offset between the two cells, value from -24 to +24 dB. Intra-frequency black cell list, List of the blacklisted intra-frequency neighbor cells. These types of cells are not considered as for the cell reselection. Cell CSG, physical cell ID. Set of PCI reserved for CSG cells on the frequency on which this field was received. The received CSG physical cell ID ranges applies if less than 24 hours has escaped since it was received, and it was received in the same primary PLMN. Coming to SIB5, carries interfrequency neighbors on different frequency, carries LTE frequencies, other neighbor cell frequencies from other RATs. The purpose of cell reselection and handover. It's having the SRB again NA, RLC mode TM, logical channel BCCH, direction from EUTRAN to UE. At the right hand side you can have a look that in SIB5 we are having these particular messages that we are going to read one by one, the messages coming under the SIB5 in the next slide. So starting from interfrequency carrier frequency information can be specified up to 8 carrier frequencies. DL carrier frequency carrier frequency helps the UE to search the cells. RX level minimum RSRP value for the interfrequency cell, value from -70 to -22 dBm. Again Pmax, maximum allowed uplink transmission power of the cell. Reselection EUTRA defines the time to trigger for cell reselection, value 0 to 7 seconds. Reselection EUTRA SF, scaling factor for medium and high mobility. Threshold X high, having the 3 points. The first one is threshold in dB used by UE for cell reselection to a higher priority. The SRX level of the candidate cell is greater than the threshold X high. The value should be 0 to 31 dB. Threshold low, having again the 3 points. Threshold in dB used by UE for cell reselection to a lower priority. Cell reselection is allowed only when SRX level of the candidate cell is greater than threshold X value and RSRP of serving cell is less than the value of threshold serving low signal within SIB3. The third point is value 0 to 31 dB. Allowed measurement bandwidth defines the term of resource blocks associated with a specific cell bandwidth. Cell reselection priority defines the absolute priority of the frequency layer. Neighbor cell configuration, information regarding the neighboring cells. Offset frequency defines the RSRP measurement offset applied to all cells on the specified RF carrier. Interfrequency black cell list. The mentioned cells are not considered for cell reselection. So that's it from my side in this video. In the next video we are continuing from SIB6 to the furthermore, and stay joined with us, and thanks for watching. Please subscribe the same channel and stay connected. Thank you.